Okay, so this is a chapter 6.3 assignment. So when you start assignment now, right? And let's take a look at the first problem. Okay, the first problem is the manager, right? The manager of this resort hotel stated that the mean guest bill is for the weekend, right? Is 600 or less. And a member of hotel's accounting staff noticed that the total charges for the guest bills have been increased in recent month, right? So accountant will use a sample of future weekend guest bills to test the manager's claim, right? Okay, so any volunteer? So what is the null hypothesis in this case? What is the null hypothesis? Anyone? What is the null hypothesis? And what is the alternative hypothesis in this situation?
The null hypothesis is that the mean guest bill is 600 or less.
Thank you. Thank you. So what is your name?
Daryl.
Daryl. Okay, Daryl, thank you. Yes. So, this is like a common belief, right? I mean, they, think that, okay, it's the guest bill, right, is the mean guest bill is what, 600 or less. However, this the staff, right, wants to test. He think that it's more than $600, right? So the null hypothesis is this, and then the alternative hypothesis is greater, right? Okay, so that's the answer, right? And then what conclusion is okay? And then the member of the hotel accounting staff suspect that there's the total charges for the guest bill have. I mean, his assumption is what he's basically has been increasing, right, in recent months. So that's why he was put this as alternative hypothesis, right? The mean population mean, right? The bill, right, is greater than 600. Okay, and number B, what conclusion is appropriate for this cannot be rejected? So the null hypothesis cannot be rejected, right? There what is enough evidence to conclude that the total charges for the guest bill have, right? So you have to really choose the answer, is or is not, okay? So basically you cannot reject, you fail to reject null hypothesis, right? When there is what? There is not enough evidence, right? And then, of course, you can reject the null hypothesis, right? When there is what? There is enough evidence, right? When there's enough evidence to conclude that. So basically, right. So I think I talk about this, right? So I want you to review my lecture, right? I talk about this null hypothesis and alternative hypothesis, right? So I want you to review my previous lecture, right? Okay. And then type 1 and type 2 error, right? Okay. So basically, the idea is that, it's, let me just review what we learned last time. Oops. Okay, so what we learned is basically, you have a populations, right? And then you got the sample, and this sample, right? The data from the sample will be used as evidence, right? So basically, this is going to be work as evidence, right? So if the sample is really follow the population, right? Then we know that, okay, so the population mean is mu. So this is a mu. And if I mean, if basically our null hypothesis is saying that it's the sampling distribution, right? By the way, this is a sampling distribution. And then if there's n is large enough, then first we know that the sampling distribution will follow the normal distribution, right? And if the null hypothesis is true, then we know that the sampling distribution, right? Sampling distribution of x bar, the sample mean, is what the middle is basically the sampling the center of the sampling distribution is what is equal to this population mean, right? So if null hypothesis is true, right? Okay, so if this evidence, the sample from the data, is really okay, so we know that this is alpha, right? And we learned that this is what? This is a critical region, right? I mean, it's a basically, I mean, this is a critical point, and you know that this is what? The critical, I mean, the rejection region, right? So the evidence, right? Evidence, it's the data from the evidence is really far away from this middle, meaning that it's located in the rejection region, right? That means what? There is a strong evidence. Okay, so if your sample data is located in this rejection area, which means it's really far away from the mean, right? That means what? There's a strong evidence, right? There's strong evidence that the null hypothesis is not true, right? So in that case, we reject the null hypothesis, right? Strong evidence means we reject the null hypothesis, right? And then take what? Alternative hypothesis, right? Okay, in opposite case, the evidence is weak, then we fail to reject the null hypothesis, right? And then, okay, so that's the opposite case. Okay, and the question number 2 is the is about type 1 and type 2 error, right? Okay, and then this is like another multiple choice. And then I highly recommend, and then before you do this homework assignment, I know that you already watched my video tutorial, but you know, I talk about type 1 error, right? Type 1 error, this is my lecture. And then I talk about type 2 error, right? And I use this example, right? So I want you to review my my lecture. My lecture is on the YouTube, right? Okay, so that's a type 1 and type 2 error, right? Okay, and then problem number 5. It's it's very similar to the first problem. Okay, this is it's very similar to the first problem. Okay, so it's so I'm gonna skip this. And also basically problem number 1 and problem number 5 and problem number 6, you know, it's pretty much, it's very similar. Okay, let's see. Must convince management that let's take a look. Okay, so if this problem, it's very similar to the first problem, the first problem. So basically, director of the manufacturing must convince that management that a proposed manufacturing method reduce the cost before the new method can be implemented. Okay, so this is very typical example, right? Because you know the manufacturer, right? They come up with a new system, right, which can reduce the cost, right? So the current production method operate at the mean cost of $220 per hour, right? So the current one is 224 hours, right? and the research study will measure the cost of the new method. So there is a current method, right? But they would like to test a new method, right? So this is a very typical scenario, right? So any volunteer, okay? So what should be the null hypothesis? What should be the null hypothesis? Any volunteer? Anyone? Null hypothesis. Okay, so first I know that it's 220, right? So this is so anyone. So basically the null hypothesis saying that, right, the mean cost, it should be equal or it is greater than the 220 or less than 220. So what is, pardon? Equal or what? Anyone else? Or the greater or less? Which one? You know, in this case, equal, I mean, yes, I think you can say the equal, but I think the better answer is, you know, hold on. Right, the better answer is, you know, I think it's the mean, right? The mean is, so the current method is, they think that the mean cost is $220 equal or more, right? And then null hypothesis, they are saying that what? No, it's, they hoping that, right, this manufacturer, right, the director actually, you know, he hoped that it's what? It's the, you know, the new system, right? The mean cost is less, right? So that's what the this director wants to prove, right? Okay. So let's check my answer. Right. Okay. So that's the null hypothesis. Okay. So it's the B and C is the same as the first problem. So I skip this. And then so this is what? So this is okay. So let's see. This problem, right? This problem is a one-tailed test, right? So for example, right? They think that its null hypothesis is what? So they get the sample, and then you know that if the null hypothesis is true, the sampling distribution of the sample means, right, is what? Is 220, right? And what they wants to prove is that the so this is the alpha, right? So this is alpha, right? So basically, they want to test if so they have a population, right? And then they get the sample, right? And the data from this sample, right? They want the sample to be in this region, this rejection region, right? It's less than 220, right? So that's what's really happening, right? So this is a what? One-tailed test, right? This is one-tailed test. And it actually is a low, right? It's a there's upper so this is like one-tailed test, right? Okay, so so that's what this problem is about, okay? But you don't have to do any calculation at this point, right? Just setting up the null and alternative hypothesis, okay? And let's look at the problem 7. Okay, so problem 7 is a type 1 and type 2 error, right? So the label, right, on 3/4 container orange juice states that orange juice contains an average of 1 gram of the fat or less, right? Answer the following questions for the hypothesis test, right? That could be used to test the claim on the label, right? So this is like in the label says that this container has a 1 gram of fat or less, right? So so basically the null hypothesis is what? So we know that it's 1 gram, right? And then it's what? It's less than, right? Less than or equal to 1 gram. So that should be the null hypothesis. An alternative hypothesis is what? No, it's that container has more than 1 gram, right? So it has contained more than 1 gram, right? Okay, so that should be the null and alternative hypothesis, right? Okay, and then they're talking about what is a type 1 error in this situation, right? What are the consequences of the making the error? Okay. So in my lecture, right? I think I talk about somewhere here. Yes. So, I talk about this, right? In my lecture. So I want you to, right? And okay, so basically, I mean, for me, I know that there are a lot of people they use their own method, but for me this is how I memorize the type 1 and type 2 error, right? So there's a null hypothesis, right? And there's an alternative hypothesis. And the type 1 error is, the direction of the type 1 error is this. So that this is type 1 error, right? And opposite is, of course, is a type 2 error, right? Okay, so the type 1 error is, you are what? Basically, at the end, you ended up what? Taking the null alternative hypothesis. Although, right? So that's like your final decision, right? Although in reality, right? On the reality, what? So the type 1 error is type 1 error, right? Is what? You basically reject null hypothesis, right? In reality, right? In reality, although in reality this is true. So in reality, even though the null hypothesis is true, you reject the null hypothesis, right? And ended up what? Taking the alternative hypothesis. And you know that this is what? This is alpha, right? Level of significance. Okay. So that's what type 1 error, right? So the type 1 error is what? Is basically rejecting the null hypothesis, right? It's rejecting the null hypothesis when the null hypothesis is actually true, right? And then, so this is a definition of type 1 error, and the next sentence is interpretation, right? So this error occurs when it is concluded that orange juice contains an average is what? Is of, more than at least, right, 1 gram of fat, when in fact it does not, right? So basically in this, if you look at this scenario, right? So basically, your null hypothesis, right? Your null hypothesis is what? Fat is 1 gram. 1 gram, basically, the population, this is less than or equal to 1 gram, right? And your alternative hypothesis is what? Is greater than 1 gram, right? So that's the alternative hypothesis. So if you look at this problem, this error occurs when it's concluded at what? It's concluded. So what is your conclusion? Your conclusion is this, right? Your population mean is greater than 1 gram. So it's concluded that the orange juice contained an average of like more than, right? More than 1 gram of fat, and that's your conclusion. However, in fact, what? In fact, this is true, right? When in fact it does not, right? And the type 2 error is what? Is opposite. And then the type 2 error is accepting. Okay, by the way, there's no difference between really like failing to, I don't really like this problem in a sense that there's not really much difference of failing to reject or the accept, and accepting. But since this is really, associated with the error, right? When you typically talk about a null and alternative hypothesis, right? basically, when the evidence, right? So when the evidence is really like, evidence is really strong, right? When the evidence is really strong, then, when the evidence is not really strong, so when the evidence is really weak, right? It's not strong, then typically you said what? You fail to reject the null hypothesis, right? And not many mathematicians or just stat people, right? They're not gonna say they accept null hypothesis, right? They never really use the word accept, right? When the evidence is weak, there is always, they said what? Fail to accept the what? The null hypothesis, right? Rather than saying, they accept the null hypothesis, right? Okay. But since it's related to, but this is talking about the error, right? And I think it's using the word accepting is more appropriate than the failing to reject. Okay, so the type 2 error is accepting, right? So type 2 error is what? Type 2 the error. So this is a type 2, right? So the type 2 error is what? Accepting. So that's your conclusion. Accepting the null hypothesis, right? When actually it is, when the null hypothesis is really like false, right? And so, and this error, right? This error occurs when it's concluded that orange juice contains what? It's less than, right? So basically that's your conclusion, right? Your conclusion is what? Your conclusion is it's less than 1 gram, right? So that's your conclusion. Although your conclusion is false, right? So that's your conclusion, right? Which is the mean population is less than 1 gram, right? When in fact it contains what? What is in fact? In fact, this is true, right? In fact, the population mean is greater than 1 gram. Okay, so that's the that's how you should solve this problem. So any question? Okay, so then let's look at the problem number 8. And I'm gonna I'm not, so problem 8 is just like the same as problem 7. So I'm gonna skip. So I think I'm gonna leave this problem 8 to you. I think you can solve this problem, but the problem 7 and problem 8 is about type 1 and type 2 error, and the format of the problem are exactly same, as you can see. Okay. So any questions about this homework assignment? Okay, so I'm done, and let's take a 1-minute break. Thank you.